These are bridges that's being destroyed around the US. In fact, more than 4,000 bridges has been destroyed in the past 5 years. And actually there's a map for this. Created by the American Road and Transportation Builders Association, there are many serious problems to US bridges, many of them are poor condition and require serious attention.
Across the country, there are 45,000 bridges in poor condition. It's just simply unacceptable.
1 in 9 of the nation's bridges are structurally deficient. American Society of Civil Engineers gives U.S. infrastructure a D+.
To answer this question, we need to go back to the 1900s. The US economy was growing very fast, and with it came a huge demand for better infrastructure. New roads and bridges were being built at a crazy rate. This eventually made private transport the best mode of transport in the US and the world, which is still the case today. However, what once made the US bridges the best bridges also made them the worst ones in the world. The crazy demand for bridges meant making them big, chunky, with a few lanes. The main purpose of making a bridge back then was to connect between A and B. Little attention was made to aesthetics, increase in traffic, and service life. The bridges that were made in the 1900s were mostly truss bridges. Although they did the job back then, they're very much an outdated type of bridges today. The issue with truss bridges is that they rely on too many steel members which are vulnerable to rust. But because of this type of bridge was very acceptable and easy to design, it was the dominant type of bridge back in that era. However, there's one flaw to those bridges. They had a design life of only 50 years, which is a very short lifespan compared to 100 years, which is the standard today. And because of that, most bridges in the US have a lifespan of only 44 years, and most have approached or passed the 50-year design life. Fast forward to today, there are 617,000 live bridges in the US. Out of those, there are 43,000 deficient bridges, which is 7% of the total US bridges. A structurally deficient bridge, as defined by the American Road and Transportation Builders Association, is a bridge that requires significant maintenance to remain in service with imposed weight limits, but is considered safe to use. Each day, around 167 million trips are taken across those structurally deficient bridges. To fix this issue, there are generally two solutions. First, keep monitoring those bridges with a scheduled maintenance to keep those bridges functional. But in many cases, those bridges are far beyond saving. In that case, the bridge will be demolished and a new bridge will be built. In the last 2 decades, many bridges have been demolished around the US. Many of them are truss bridges. Some of those old bridges were replaced by girder bridges or simply supported beams, but for longer bridges the majority were replaced by this, the cable-stayed bridge. There are many reasons why this bridge is now America's engineers' favorite when it comes to making new bridges. First of all, it has fewer components consisting of cables connecting the deck and the pylon, and the deck can be constructed as soon as the first pylon is built. Cable-stayed have a design life of 100 years. Its longest span can go anywhere from 60 meters to 1,104 meters. Compare this to truss bridges, which can go anywhere from 75 meters to 400 meters or 1,300 feet. This makes cable-stayed bridges perfect if you are building bridges over water, since you will be constructing fewer piers over water, or in some cases, none. This not only makes it easy to construct, because it uses fewer materials and it has easy construction method, but it also very cost effective, aesthetically pleasing, and easy to maintain. Cable-stayed bridges are simply a marvel of engineering. But why those bridges were not constructed in the 1900s instead of truss bridges? In the early 1900s, cable-stayed technology wasn't as mature as truss bridges. There were many problems with cable-stayed, and they did snap a lot. The earliest design of cable-stayed dated back to 1817, the Dryburgh Abbey Bridge in Scotland. This bridge was 79 meters or 259 feet long. After it was opened in April that year, it collapsed in January 1818, just 6 months after it was opened. This bridge was ultimately replaced by a suspension bridge. There were many problems with cable-stayed that needed to be solved. First, engineers needed to maximize the efficiency of the cables by determining the forces each cable is taking. Second, finding a solution to anchor those cables. And finally, using cables that are ductile enough but have enough strength to carry the bridge. This ultimately meant that longer bridges were most likely to be suspension bridges in the US. Suspension bridges transfer the load from the deck through vertical cables connected to the main two cables that span between the two towers, which are anchored at the end. Suspension bridges only make sense to construct when it requires longer spans, and it can go anywhere from 100 meters to 2 kilometers. However, if we compare this to cable-stayed bridges, which can go anywhere from 60 meters to 1,104 meters. Things changed in 1953 with the construction of the Strömsund Bridge in Sweden. This bridge has incorporated most of the technology that is used in modern cable-stayed bridges. And since then, cable-stayed bridges were an attractive solution throughout the world. But things were very slow in the US, and cable-stayed bridges were not adopted until the 21st century. This meant that mid-sized bridges were likely to be constructed with the truss bridges that eventually became obsolete. What made a significant improvement in bridge design today is computer modeling, which wasn't possible in the 1950s. It's not only improved the way we design bridges, but also improved the aesthetics. This meant maximizing the efficiency of each cable and reducing the chances of errors. So in a way, in the previous century, truss bridges were easier to design and construct compared to cable-stayed. Having better roads doesn't always mean less congestions. While the US have the best motorways in the world, it also has the world's worst congestions. Compare US to European cities, which have moderate infrastructure, but it has excellent public transport. This has taken a significant load from motorways, which ultimately reduced congestions. This is why US have a significant bottleneck to its bridges. In 1950, the US population was 158 million, and today it is 332 million. US population is expected to grow to 423 million by 2050, which is a 22% increase or 62% increase since 1950. This means that even if all structurally deficient bridges were destroyed and replaced with wider and better bridges in the next 5 years, it will not improve or change US traffic. In many cases, it will be worse if there is no plan to improve public transport. Thanks for watching, and if you enjoyed this video, you could like and subscribe to the Young Hero Engineer. I will see you in the next video. Cheers.